Alright, so in this video we've got a window that's constructed like is drawn on the screen. So we've got this rectangular part at the bottom, and then we've got this top part that is supposed to be a semicircle. And so the conditions that we're given is that we know that the perimeter of the window is supposed to be 16 feet. And given that constraint, we want to find the dimensions of the window that would give us the maximum area. So we know that the function, we want to create some function that represents the area of the window, and so we're going to have to split this area up into two sections. We've got the rectangular section and the semicircle section. So we might remember that the area of a circle is pi times radius squared, and we can see it's already labeled in the picture. The radius of this semicircle is 1/2 of this distance, which would be given as x over 2. So to write the area of the entire window, the rectangular region has an area of length times width plus, and then so we're going to take the area of 1/2 of a circle whose radius is x over 2. So pi times the radius squared. So that's going to give us xy plus, this will be pi over 2, 1/2 times pi times x squared over 4 when I square that. So this is what, xy plus pi, this is going to be pi over 8x squared, pi over 2 times 4, pi over 8x squared. Okay, so I've got this issue that my area function, I need all in terms of x. I need to get rid of this y, and that's where I'm going to use that the perimeter is 16 feet. So the perimeter being 16 feet, so going around the rectangular part, I'd have y plus another y plus an x, so 1x, 2 y's. And you might remember that the circumference, the distance around the outside of a circle, is pi times the diameter. Right, we can see the diameter of this circle is this distance, which is x. Right, so I'm going to have pi times the diameter, that would be pi times x, but I want to take half of that because I've only got half of the circle, so 1/2 pi times x. Right, so now I'm going to take this equation and I'm going to solve it for y. So I want to get this term and this term over to the other side. And then to get y completely by itself, I'm going to divide all the way through by 2, or multiply by 1/2, I guess is kind of how I'm looking at it. And then I'm going to go back and substitute this into my area equation for y. So if I do that, my area function is going to be x times all this stuff plus, I have that other term from the area function, pi over 8x squared. And I'm going to go ahead and simplify this, multiply through by x. 1/2 x squared minus 1/4 pi x squared plus pi over 8 x squared. And so there's my area function, all in terms of x. So I can take the first derivative. Term by term, I'm just going to use the power rule, right? 1/4 and pi is a constant, pi over 8 is a constant. So really I'm just bringing the 2 down with the power rule, bringing the 2 down with the power rule, so this would be 8. 1/2 times 2 is 1. I'm going to have 2 times a 4th right here, which is 1/2 pi x. 2 times an 8th, which is, let's see, that'd be pi over 4 x. And then I set this equal to 0. Alright, so to solve this guy for x, I need all the terms with the x on one side of the equation. And so I'm just going to shift all these terms over to my right side. Let's see, let's write these consistently. This would be pi over 2x minus, move this term over, that'd be pi over 4x. And since I got all the x's on the right side here, I can factor an x out. And so that tells me that x is 8. Divide by all of these guys. That'd be minus pi over 4. And that would be an acceptable way to write the value of x. You might simplify this a little bit. If you wanted to, you could say this is 8 over, I need a common denominator here, so I'd have to multiply by 2, multiply by 4 over 4 to get the common denominator, so I'd have what, 4 plus 2 pi minus 1 pi all over 4, that'd be what, 8 over 4 plus pi all over 4. And if I take and multiply by the reciprocal of the denominator, 4 times 8 here would be 32 over 4 plus 5. 32 over 4 plus pi. And we could, of course, let's see, if we want to double check for sure that this gives us the maximum value, we could take the second derivative. I suppose we can do that real quick. My second derivative here would be negative 1 minus pi over 2 plus pi over 4. Negative 1 minus pi over 2 plus pi over 4. You can, without too much effort, I think, verify that 1, this is constant, 2, that's always going to be less than 0, right? So any x value that you plug in to this second derivative is going to give you a second derivative less than 0. That means your function's got to be concave down. It would mean that you have a relative max at this x value. And I will leave this last part up to you, but the last part would be that you need to find the y value. And of course you had an expression for y way back up here, right? So what was it? 8 minus 1/2 x, 8 minus 1/2 x minus 1/4 pi x. So to get the value for y, of course you would take this x value and plug in there. But certainly you're almost there by getting this x value, and you should find, if you simplify, you should find that y is 16 over 4 plus pi. Of course there's a couple of steps in there, but I'm going to leave that work to you. So derivative isn't too bad there. A lot of that is just the algebra and the simplifying. But anyway, I think that gets us to where we wanted to be.